Okay, good afternoon. Did you hear me? Hello.
Hello, sir.
Hello, can you hear me?
Yes.
Okay,
I
thank you. Okay. Okay, so today we get started from the chapter 8. There is the variation implementation. Okay, so before I always mention how many important factors we have to do our evaluation well. There are four factors we have to get to know. So first factor is the future cash flow. How many future cash flows you have? You have a give the approximated estimation to your future cash flows. Second factor, there is the uh, appropriate discount rate. It is used in your denominator. Okay, so future cash flow you estimate it used in the numerator, and how many periods you have after you have this kind of investment. So maybe you just have 2 periods, you have 3 periods, you have many periods. So the sub factor is time period you have. Last factor is the terminal value. Terminal value, we know not all investors to hold the contingent claim until forever, right? So one day you willing to sell it to another investor. So what debt is that debt? Okay, so you have to tell yourself what debt is your terminal debt. Okay, so there are four factors. Okay, I repeat that again: future cash flow, discount rate, time periods, and terminal value. Okay, so how we can give appropriate discount rate to estimate cost of the capital, cost of the equity, okay, related to the cost of the fundings from some investors. Okay, here we provide is the well-known formula proposed by Sharp Niner, okay, and at 1963. Okay, this formula is the risk-free rate RF plus the beta system risk times the asset market asset return, ERM minus RF. The beta times the ERM minus RF, which is called the risk premium. Okay. Risk-free rate we can take from the historical data of the intermediate term the government bonds. Yeah. Or risk premium market, you can focus on the return to an international portfolio during the period 1900 to 2014. And he can help you find a market risk premium of 5.0%. A beta is adjustable and reflected by risk. So you have that from the historical association between a firm specific and market returns. Risk-free rate. Okay, so this the number from the chapter adds by some historical data. Okay, so about the 1.3%. Yeah. Okay. So yeah, probably you estimate the risk-free rates from the different database. So like you take the historical data from the European government, the database. So after estimation, you get the 2.2%. Yeah, and yeah, so this about the long-term inflation expectation. Okay, so by the future effect, we know the future equation, future effect, the 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 rates equal to the expected long-term inflation plus the real interest rate. Okay, so that means the expected long-term inflation equal to the 2%. The real interest rate is 0.2%. Okay. Next, the market premium of 5.0%, also from the historical database. The beta, okay, you can run the regression, okay, on the monthly returns, okay, between the March 2010 and the February 2015. Okay, so you can get a beta. Okay, the beta estimated the beta from the regression. You have the 0.45. Okay, so you input all available numbers into the formula. You can get a cost of equity roughly 6.7%. Okay, so here's if you find the cost of capital not only flatted by systematic the risk beta, and you want to compare that and more, and considering the font size effect. So here the formula will be changed by the RF plus risk premium plus the size effect. Okay. Effect changes in leverage. Sensitivity of the equity performance to economy why changes increase in leverage. Okay, so here the beta equity can be calculated by tax rate, debt ratio, and the beta of business assets. Okay, so for take example, So the average ratio after tax book value of debt and the market value of equity was 0.10. Estimates at a man business asset beta, we have the 0.41 after we input all the parameters, okay, into the equation. Note that if the forecasting assumptions imply that HMN increases its leverage, its equity beta will also be expected to increases. The relationship between equity and operating asset betas depends on leverage and non-operating investments. Okay, so the beta we can infer from the previous equation, and then we have the beta equity can be composed of the beta net operating assets, beta investment assets, and the beta debt, and it's the weighted respectively we have the 1 plus 1 minus tax rate times debt minus investment assets divided by equity, and investment assets over the equity, and 1 minus tax rate times the debt over the equity. This relationship builds on this idea that the beta of portfolio asset is weighted average assets individual betas. Often it is reasonable to assume that the beta of non-operating investment and debt is close to zero. A condensed fair value balance sheet. So write the column. That is the crimes, contingent crimes. There you can find the crime of the debt, crime of the equity. In the right column, there is the assets, including the fixed assets and the liquidity assets. Okay, so the condensed fair value balance sheets, left and the right, the sides of equity are both equal to each other. Next, estimating the WACC for cost of the capital. The appropriate the discount rate to value a company assets is the WACC. The WACC takes into account debt and equity sources of financing. It's the weights respectively debt of the over the debt plus equity and the equity over the debt plus equity. And it's the cost of the debt calculated by interest rate, cost of equity calculated by the CAPM. Okay. Okay, here. Okay. All right. The detailed forecast performance assumptions underlying the forecast are all important. Strategy analysis is critical to determine if current performance is sustainable. Accounting analysis helps understand a company's current performance. As reported, the reliability of reported information used in forecast. Typically, selected financial statement line items are forecasted instead of complete financials. Okay, wait a moment. Okay, sorry. So take a break, 5 minutes. Okay. Okay, so we take a break, 3 minutes. Okay, I come back. All right, so uh, this the table So this the 10 years, 10 years of the forecasting performance for HMM, the table. Okay, so the number is quite different, right? In every year. So that as you have a look at 2015, 2016 to the 2024. So this is HMN abnormal profit at the 2015, which is the 19,092. At 2016, 23 for 56. Okay, so last year, 16 at 97. Okay, and there is the description of 10 years abnormal profit. It's the ROE. We know ROE, the definition is return on equity. Okay, so abnormal ROE here providing by the 33, 36, 39 until the 15.4. Free cash flow to equity. So we know the total free cash flow deduction of the debt. So we left the free cash flow for equity holder. So and the 10 years free cash flow to equity, we have 18.18048. Okay, until the last year 21,951. Okay, so the abnormal profit growth. Okay, profit growth, we know that profits here, you use the next year profit minus this year. That is your growth. Okay, so here you check that. So you check that here. So minus. So plus. Okay. So 23 for 56 minus 19,092.8. You have the profit growth at 2016, 4363.2. Okay. As a variation, okay, here, okay, so this NOPAT, net here after tax, net operating after tax, okay, is RA abnormality is the 11.7 until 4.5. So free cash flow from operations. So here, equity, okay, so 0.928 to 0.472. Net operating assets 0.930 to the 0.485. Okay, this one. Okay, so check here. Discount rate to equity, discount rate to net operating assets. That's different. Okay. So here's, okay, you check and in each column the different discount rates, different risk. Okay. So as 2015 at the 2016 at the 2024, so that provides different discount rates with a different number. So they stand for different risk over the time. Okay, so please remember, asset the risk you have quite different equity risk you have. Okay, so the next terminal value. The terminal value is the final year, the forecast, and represent the present value or future abnormal profit or free cash flows for the remainder of the first life. Okay, so first life, how many years you expect? You expect the company is alive. Maybe it is the very strong, okay, industry, so they can survive until the infinity, right? Okay, or is so weak. Maybe they just can run its business 3 years. Okay, so the first life, that is the terminal, okay, the terminal debt, terminal debts over there, how much terminal value you have. Okay, so okay, here, so it's our last important factor as before I mentioned. Okay, so this one, so terminal value might be forecasted with growth in abnormal profits and the cash flow at a constant rate. A price, a multiple, might be used to calculate the terminal value. Selecting the terminal year, 5 to 10 year forecast horizon shows service for most firms. Terminal values under the competitive equilibrium assumption. Okay. Okay. So yeah. So let me use this. Okay. So this one. This one. Okay, so this one, the timeline, okay, we know the initial time, okay, the next period. Okay, so can you answer me, what's your terminal debt? So obviously the terminal debt is the one, right? Okay, so your current value here, current value, we know reflected by dividend one, and at the terminal debt, what you have, the residual value, we know the P1, right? P1 means you have the right, to sell stock to another investor, right? Okay, so over the time you get the P1. Okay, and we know the here D1 plus P1, that's your future value, right? Okay, so you need to multiply that by discount rate, right? So here we suppose that our discount rate 1 plus r. Okay, this one. Okay. Okay, that is your current value, right? So P0. Okay, P0. Okay, so P0 determined by the D1, P1, 1 plus R, okay, and the time, okay. So here, terminal value will happen at that 2, right? Okay, at day 1, at the day 1 you have a D1, okay. At the day 2, not only have a D2, also over the time you have the right to sell the stock to another investor. Another investor will pay you with the P1, okay? P2, sorry, because that will happen at the day 2, okay? So what your current value? So current value P0, okay, the D1 over 1 plus R plus the D2 over P plus P2. 1 plus R, okay, over 2, okay. 1 plus over the 1 plus R, the power of 2, okay. Okay, so the third time 9, so P0, we can induct P0 can be D1, D2, D3, and the receiver savage value P3, okay. Also you can sell it to another investors. Another investor get you your stock and will pay you the P3, okay. So this one, okay. The last case, if there's no terminal debt, okay, you will hold it until forever. So the P0 D1 over 1 plus R D2 over 1 plus R square, okay. dt over 1 plus R power of t, and okay, we stop at the infinity, so we have d infinity plus p infinity over 1 plus R infinity, okay. And we know this one infinity to finite number, d infinity plus the p infinity, okay. So 0 1 0, okay, this one. So we have a little bit arrangement for the equation. So the d1 1 plus r, d2 1 plus r squared Okay, so this one, summation t from 1 to infinity. So here the dt over 1 plus r power t. So this one, okay. Yeah, so okay, so different case, different terminal debt have the terminal terminal debt. Okay. So any question? I just let you know, um, the terminal debt is important. Okay. Yeah. So different cases, you have to think about that. What is its terminal debt? Yeah. Okay. So maybe the terminal different cases, the terminal debt um, has actually different debts, right? Okay. Any question? Hello? Anybody here?
No, sir.
Okay. Thank you.
No,
Uh,
sir.
uh you remember that if we said okay here. Okay, so here if okay we can uh, rearrange that by the formula d1 over 1 minus r minus g. Okay, okay, so this is our important equation based on the ideal assumption. The ideal assumption is that d2 equals to d1 times 1 plus g, d3 equal d2 1 plus g. Okay. Okay. This is they has the growth, the constant growth rate. Okay. So d2, d3, d4. Okay. dt have a dt minus 1 times 1 plus g. Okay. Okay, so if you have this kind of the ideal assumptions, so you can arrange that for this equation into the new equation d1 over minus g. Okay. Okay, so this one, if hello, so if that we use the terminal value, this one, we can imagine that this one. Okay, the d1 to d3. Okay, d1 to d1, d2, d3 you received, and the p3 you can imagine that. Okay, this one. So that means okay, the p3 it should be so if you suppose that after term the at the terminal dash 3 they reflect reflects the d4 d5 d6 until forever. Okay, so we know this 1 plus r here, 1 plus r square, 1 plus r this. Okay, and so and we know based on the ideal assumption, the d4 equal the d3 1 plus g. Okay, d5 equal d4 1 plus g. Okay, based on the ideal the equations, so we can express that as new equation. Okay, so new equation is the d4. Okay, so this one, d4 r minus g, right? Okay, d4. Okay, the p3 can be expressed as the d4 over r minus g. Okay, and substitute it into the here, and we have, okay, the bracket is the same, plus this one, the d4 over r plus g. Okay, and your denominator 1 plus 3r 3. Okay, and we know the d4 can be estimated as the d3 times 1 plus g. Okay, so this one is a bracket plus the d3 times 1 plus g. Okay, over r minus g. Okay, yeah, over 1 plus r 3. Okay, so this r minus g times 1 plus r 3 here. So d3 1 plus g. Okay, yeah, so the brackets, the d1 1 plus r, d2 1 plus r square, d3. Okay, 1 plus r, this one. Okay, so this one, okay, p3 can be the p3 can be defined can be find by the d3 times 1 plus g over the r minus g. Okay, yeah. So about my induction, any question to you? Hello, any any question?
No, sir. Thank you.
Okay. So this is important element in valuation. Okay, that's your terminal value. Okay, terminal value, this one. Okay, terminal value. Okay, we take a break. Okay.